All right, let's start today by giving you the formal definition of what a significance test means. This is a formal procedure where we're going to compare observed data with a claim. In the earlier video, we learned that this claim is called our hypothesis. So we're going to take what we see and we're going to compare it to a claim whose truth we want to assess. So to review the free throw activity, we did a sample of free throws, we got my proportion, and we are comparing that sample data to the hypothesis that I really was an 80% free throw shooter. So if you would pause this video, read this scenario, read question number 1 and answer it in your head. Right? What additional information do you need to evaluate this statement? Well, you would need to know how many males and females work at the company in order to assess the claim that gender discrimination did occur. So I will tell you that in this company, there are going to be 60 females and 120 males. So what I'd like for you to do now is, how can you investigate the gender discrimination claim? I want you to detail a process that could be used. So press pause and think of the free throw activity and some stuff you learned in chapter 5 and come up with a process that could investigate this claim. So there's a lot of different answers that you could have come up with here. The first thing you had to realize, though, is that 60 females was 1/3 of the 180 people employed at this company. So you had to think of ways to model 1/3. So some of the ways you could model it was you could roll a die and let the sides that show 1 and 2 represent women and 3 through 6 be men, because 2 out of 6 is 1/3. You could do a spinner and let 1/3 of the spinner represent women and 2/3 be men. You could do a random number generator. There's all kinds of different ways you could use that random number generator. So then remember, with a simulation, we have to repeat it many times and we will record the number of men and women. I decided to do it 25 times. And then we'll calculate the proportion of females who were selected. Now, I did ask you guys to do the data collection through our Google Classroom when I asked the question and I asked you to go and roll a die 25 times. And thank you for that, because I did not really want to roll a die a whole lot 25 times. So here is a dot plot of what you guys did. So there are 47 dots here. What percentage of the dots represent half or more females being laid off? Okay. That's these dots right here. 3 out of 47. So when I take 3 and divide it by 47, I get 0.064. So what percentage of the dots represent half or more females being laid off? 6.4%. So to interpret this percentage in context, assuming that the lottery was carried out fairly, there is a 6.4% probability of getting a sample proportion of 0.5 or higher. Is this convincing evidence of gender discrimination? And I hope that at this point you know the answer is no. We have our 5% benchmark for statistical significance. And since 6.4 is greater than 5, then it is likely that, or it is very plausible that we could have seen the outcome of 5 men and 5 women being let go in this manner if the lottery was fair. So we have no reason to believe that the lottery is not fair. So this number is not statistically significant. So we just basically did a significance test. The introductory activity and this activity give you good basics. Well, let's take and bring this into focus for you. When you guys are writing significance tests and you are going to assess the truth about a claim, you will always have your hypothesis. What is it that you think is true, or you're trying to test to see if it's true? Your null hypothesis is going to be H sub 0. And your null hypothesis is always about your parameter. And the two parameters that we're used to working with are mu for mean and p for proportion. These are going to equal whatever your claim is. So yesterday, p equaled 0.80. That was the claim. I claimed I was a 80% free throw shooter. Today, the claim was that 50% of females were being laid off. Was that fair? Your alternative, H sub A, is going to be your parameter, either mu or p, and it's going to be greater than, could be less than, or it could be not equal to the null value. Yesterday, or in the free throw activity, our alternative hypothesis was p was not equal to 0.80. So remember, the null is the claim, and the alternative is based on our sample. What did we think is not true? Did our sample give us a number less than the claim, greater than the claim, or a number that was different from the claim? So the p-value is the probability of getting the results, or more extreme, purely by chance, not change, chance, if the null is true. So we will always start with the assumption that the null hypothesis is true, and we're looking for evidence to support that or not. When you are writing a conclusion for your significance tests, it has to include 3 parts. The first part is you're going to do a comparison of your p-value to alpha. So let's talk about your alpha level for just a minute. When we have been working with statistical significance, we have always said that 5% was our cutoff. So that is your alpha level. That is called your significance level. Now, your significance level is going to be totally up to you if you're doing this in the real world. You can set whatever significance level you want it to be. You will see the most common significance level is 0.05. So that's why I've always said this cutoff is for statistical significance. So you're going to compare your p-value to alpha. So I'm going to go back up to this, if you will remember. This probability, that's your p-value. Oh, that's pretty fat. I'm going to do that again so it doesn't look so gross. This is your p-value. And then this is your alpha level. So your conclusion has to link this p-value to your alpha level. Just like we did right here. Since our p-value of 6.4 was greater than 5, our result was not statistically significant. So then we're going to use this comparison to make a decision about the null. You will never, ever accept that the null hypothesis is true. Ever. Then you have to explain what this decision means in context. So your alpha level is your significance level, which either will be told to you or you will get to pick. If you are not given an alpha level in these problems, use 0.05 because that's what we're very comfortable with. We've been using it for a long time. And if your p-value is less than alpha, you do have a statistically significant result. Okay, so before we actually do a problem, and I'm going to put all this into practice, I want to talk a little bit about this never ever accepting the null hypothesis. And I want to talk about it in terms of a court case. When someone is brought to trial, let's say for larceny, and they have to go in front of a jury, what are the two results that a jury will bring back? Guilty or not guilty? So if we think about a crime, the person either committed the crime or they didn't. And in America, we assume that someone is innocent until proven guilty. So your null hypothesis would be that the person is innocent. Then we go to court and we look for evidence for or against the person's guilt. So our p-value is evidence for or against our alternative hypothesis being true. Your p-value is speaking towards the alternative. It is not giving you the truth of your null hypothesis. That's why when a jury comes back and delivers their verdict, they do not say, oh, this person's innocent. They say, we do not have convincing evidence to say they're guilty, so we're going to say they're not guilty. So keep that in mind. You're never, ever going to say that the claim is true. You're going to be talking about the evidence for or against what you think is happening based on your sample result. Okay. All right, let's do the check your understanding. Calcium is a vital nutrient for healthy bones and teeth. The NIH recommends the calcium intake of 1,300 milligrams per day for teenagers. The NIH is concerned that teenagers are not getting enough calcium on average. Is this true? Let's state the appropriate hypothesis for performing a significance test. Be sure to define the parameter of interest. Let's start with that. Our parameter of interest is mu. Now, how did we know that? The word average. So we don't know the true average, but we have a claim that we think we have the true average. So the true mean daily calcium intake. So your null hypothesis. So your hypotheses are always written with the parameter of interest. So we think that the true mean is 1,300. But what is the concern here? The NHS is concerned that the students are not getting enough calcium. So they're concerned that the true mean is really less than 1,300. So that is your null and that is your alternative hypothesis. So researchers decide to perform a test using the hypotheses stated in number 1. They ask a random sample of 20 teens to record their food and drink consumption for one day. The researchers then compute the calcium intake for each student. Data analysis reveals that X bar equals 1,198 milligrams and the standard deviation of the sample is equal to 411 milligrams. Researchers performed a significance test and obtained a p-value of 0.1404. So what would this mean? Explain what it would mean for the null hypothesis to be true in this setting. This would mean that the mean daily calcium intake is actually equal to 1,300 milligrams. Question number 3 is going to ask that we interpret the p-value. So this p-value of 0.1404, remember that is a probability. That is the probability of seeing this sample result of 1,198 if the claim was true. So if the true mean consumption was 1,300, the probability of seeing the result that we saw is 14%. Or we can say, assuming the mean daily calcium intake is 1,300 milligrams, there is a 0.1404 probability of getting a sample mean of 1,198 milligrams or less purely by chance. So what conclusion would you make at the alpha equals 0.05 level? Well, I think 0.14 is very much so greater than our alpha level of 0.05. So what that's saying is since this result that we got, that 1198, since the probability of that happening is greater than our alpha level of 5%, then we don't have any evidence toward the null hypothesis towards the alternative hypothesis being true. So since 14% is greater than alpha, we have no reason to think the claim is not true. So in an effort to try to avoid accepting the null, I have created a template for you. And if you follow the template, you will be able to properly get all three parts of your conclusion, and you will be able to make it make sense. So here's the template that you'll use for a conclusion for a significance test. Since the p-value of blank is, remember we have to make a comparison to alpha. So we're either going to say the p-value is less than or greater than alpha. Based on that comparison, we will either reject or fail to reject the null hypothesis. So if you'll notice what I did when I color-coded it, if I say that the p-value is less than, then we will reject the null, h sub 0. We do not have evidence towards the alternative, and we have to make sure we put it in context. So let's take this problem and let's rewrite the conclusion following this template and make it look very pretty. Since the p-value of 0.14 is greater than 0.05, we fail to reject our null hypothesis. We do not have convincing evidence to say that teenagers are not getting enough calcium on average. So your conclusion has to have those three components. Since the p-value is greater than alpha, we will fail to reject the null. We do not have convincing evidence to say that teenagers are not getting enough calcium on average. Again, please be very careful that you are not saying that the claim is true. We don't have evidence to support the alternative. We don't have evidence to support that the teenagers are not getting enough calcium on average.